Hello and welcome to this tutorial. From this tutorial we will understand Google stock price prediction with RNN and LSTM. Let us begin. First we have to do installation and setup. Pip install TensorFlow GPU execute. It will take some time to install. After the installation, import TensorFlow. Import TensorFlow as TF execute. Now check the version. Print TF dot version execute 2.0. So we have successfully installed and imported TensorFlow 2.0. Now import other libraries. Import numpy as np. Then import pandas as pd. And after that import matplotlib .pyplot as plt. Execute. Great. So we have completed installation and setup. That is, first we have installed TensorFlow GPU version. After that we have imported TensorFlow and verified the version, and then we have imported these three important libraries: numpy, pandas and matplotlib. Now we have to do data pre-processing. Add one more section. Step 2, data pre-processing. Great. Now we have to download the Google stock prices. To do that, go to this website finance.yahoo.com/code/GOOG/history. Now scroll down. From here we can download the data. You can see here, first option is time period. Now click here. We can select start and end date. So here I will download two different datasets. One is for training and one is for testing. For the training purpose, I will download data for 5 years. That is from November 2014 to October 2019. And for the testing purpose, I will download data of November 2019. I have already done that. So cancel. Let us explore the dataset. So these are the two datasets, training set and test set. Open training set. In training set we have data of 5 years. November 2014 to December 2019. Total 5 years. And these are the columns: date, open, high, low, close, adjacent close and volume. Let us understand these columns. First column is date. Second column is open stock price of that day. Then the highest stock price of that day. Then the lowest stock price. And this is the closing stock price. And after that adjacent close. And at the end volume. So there are total 7 columns in this dataset. Let us check the number of observations. (1258) minus 1, 1257 observations. We are not considering this row as observation, the first one. So total number of observations are 1257. Now close this. Check the test data. In testing data, there are same number of columns, these 7. And there are total 20 observations. These 20 observations are of the month November 2019. Now close this. Go back to Google Colab notebook. First we will import the dataset to Google Colab. Importing the dataset. From google.colab, import files. Define an object uploaded. Files dot upload. Execute. Execute one more time. Great. Choose files. Select these two files. Open. Great. Now these two files are in Google Colab. To see these files, click on Files, refresh. You can see here test_CSV and training_CSV. First we will read this file, training set. Define a variable training data pd dot read_CSV. Copy path and paste. Execute. Great. Let us explore the training data. Type training_data dot head. Execute. So these are the first few lines of this data. You can see the date 3rd November 2014. This is the first stock price of November 2014. Let us check the tail. Training_data dot tail. Execute. So these are the last few lines of training dataset. You can see the date here 30 October 2019. So in training dataset we have stock prices from November 2014 to October 2019. Now check the information. Training data dot info. Execute. So there are total 1257 entries from index 0 to 1256 and there are total 7 columns. These are the column names: date, open, high, low, close, adjacent close and volume. And these are the number of entries in these columns, 1257. And this is the object type. Add one more cell. Now define one more variable, training set. This will be the actual data on which we will train RNN network. Type training data dot iloc. We will select all the rows. In training data we will select only one feature, this one, column open. Now scroll up. In Python programming, index location starts at 0. So we have to select this column as feature, index 1. But we want to select array, so add the range, :2. In Python programming, upper bound is excluded. Index location starts at 1 and upper bound excluded. That means we are selecting only one column. This one, column open. By doing that, we are making an array. Till now we have selected a data frame. To convert this data frame into NumPy array, type dot values. Now it is a NumPy array. Execute. Great. Let us check the information about training set. .info. Execute. So it has no attribute. Let us check by another way. Training set dot shape and training data dot shape. Execute. So in training set there are total 1257 observations, and same in training data 1257 observations. But note down here, these are the number of columns. In training set we have selected only one column, and previously we have 7 columns. So in training set there are 1257 observations and one column. After selecting the training set, we will apply feature scaling. Now note down here, there are two ways to apply feature scaling: standardization and normalization. This time we will do feature scaling with normalization. In RNN, we use normalization. First we have to import the library from sklearn.preprocessing import min max scalar. Now define an object here sc. We are defining this object of this class min max scalar. Min max scalar. Here we will specify one parameter, feature range 0, 1. Now define one more variable, training underscore set underscore scaled. So this will be the training set after feature scaling. Type this object sc, then apply the method fit underscore transform and in parentheses training set. That's it. Execute. Great. So we have successfully applied feature scaling. Let us check the data set. Training underscore set underscore scaled. Execute. Great. As you can see here, these values are scaled. Let us revise what we have done in this tutorial. First we have completed installation and setup. That is, first we have installed TensorFlow GPU version. After that we have imported TensorFlow and verified the version. Then we have imported these three libraries, NumPy, Pandas and Matplotlib. After that we have started data pre-processing. First we have imported two files, test set and training set. Then we have created a variable training data, and in training data there are total 1257 entries from index 0 to index 1256, and there are total 7 columns in this training data, and you can see other details here. After that we have defined one more variable, training underscore set. This will be the actual data on which we will train our RNN network. In training set we have selected only one column, this one, open. And after that we have applied feature scaling. Now note down here, there are two ways of applying feature scaling, standardization and normalization. Here we are doing normalization. And to do that we have imported this class min-max scaler from this library sklearn.preprocessing. So this tutorial ends here. I will see you in the next one. Till then, happy learning.